then that sort of activity can occur, and reveal your anonymity that way. Correlation between Tor and non-Tor is a big one that can happen. This is for cache. This is kind of a surprise because you can inject unique identifiers inside the cache of inside of an element that's used to render a page, and then if that element is cached, you can then traverse the DOM and look for that unique identifier inside that cache, like iframe or whatever. Cookies are also a really particularly deadly thing to have with Tor. And there's a scenario. So, for example, mail.google.com. If you go to https://mail.google.com, you think you're secure. You say, okay, I'm only going to be using this site through SSL. You are visiting entirely, or you only use the SSL version of mail.google.com. Then you say, okay, I'm done. You just turn on Tor without thinking about it. You are then vulnerable to the fact that the Gmail cookies are not tied to SSL traffic. So a malicious adversary on your local network or on the Tor network can insert a document element for mail.google.com, cause your browser to transmit the GX cookie, and then that adversary can then use that GX cookie to log in as you, send emails as you, fetch your entire inbox or whatever. So I mean, this is something to keep in mind for DEF CON and for the BlackHat network. You want to make sure that when you're done using Google, even if you are using that or your mail or even pretty much any service that you're not sure of the status of the cookies, whether they're tied to SSL or not, you want to make sure that you clear those cookies as soon as you're done using that service, because somebody with AirPoon or whatever can just inject a content element into CNN.com when you visit it and grab your GX cookie and start sending email as you, or start downloading your entire inbox. And this can happen over Tor, it can happen at your local wireless network or whatever. So it's a good reason to clear your cookies regularly. History disclosure is another big one. Turns out that with JavaScript, you can query about 10,000 URLs per second to see based on the visited attribute. So if you notice when you're viewing a website, the links that you visit are purple or red or whatever, depending on the style sheet of that website. But then which is different than the links that you don't visit. And this history can be queried at an astounding rate, and you can use this to determine what Google queries have been mentioned, have been made, and if the user has visited a particular website for Chinese dissidents or whatever, the Great Firewall could potentially do this to see if they visited certain Wikipedia pages or what have you. Location information is another one. You don't want time zone being transmitted, or your locale. Those can be dangerous. Basically, give away what jurisdiction you might be in. And then general anonymity set reduction. This basically falls under user agent strings and other properties of your browser that are just going to limit you to essentially being like the only Iceweasel Debian user on the network. And history records are another thing that comes in for that local confiscation scenario. So I actually did some work on improving Tor button to address every one of those vulnerabilities. We disable plugins while Tor is enabled. We'll isolate the dynamic content for every Tor load state. So actually go through and tag every single tab that you load with the Tor state that it's loaded under. So if it's loaded under Tor is enabled, that state is associated with that tab. If it's loaded under Tor is disabled, then that state is associated with that tab. And using the Firefox extension NSI content policy API, we then check to see if any document fetched from that tab corresponds to the current Tor state, and if the current Tor state corresponds to the fetch state, then we allow it. Otherwise, we disable it. So that handles CSS pop-ups and handles JavaScript fetches. and all that other nasty stuff. We also disable JavaScript in general for pages that were in an opposite Tor state. Cookie jars, to try and protect your Google cookies, we have a cookie jar mechanism contributed by Colin Jackson that basically puts all your non-Tor cookies into this jar that and clears your browser cookie state while you're using Tor, and then restores it afterwards. You also have the option of clearing your cookies entirely. Similar things happen with cache. We make sure that it never writes to disk. History management, we're able to, using again code from Colin Jackson, block all the history disclosure attacks, CSS-based attributes, JavaScript DOM inspection. Basically, we just tell the browser, there's an interface that you're allowed to tell the browser if a link is visited or not, and you can re-implement that interface and basically say, okay, I haven't visited anything if Tor is enabled and this setting is enabled. User agent spoofing, we do that, do it a bit better than the other extensions. The user agent switcher extension misses a few key properties of the Navigator JavaScript object that we fill in and make it look like you're a Windows user using the most recent version of Firefox. Time zone and locale spoofing, this is a bit more complicated. We essentially just hook the JavaScript date object and cause it to report GMT times always, and also report that you're an English user using the English char set. So let's see how much time we got. So to demonstrate this extension, I have a list of essentially several common browser information disclosure pages here. Oops. We'll fetch all these via not Tor and then refetch them during Tor and show you guys that in fact Tor button has blocked all of these. We have CSS history disclosure, date disclosure, using plugins to bypass proxy settings. I'm going to save that one for later. Using non-JavaScript methods of determining your history, the CSS attribute essentially, and CSS pop-ups. So here, I don't know if you can read that. Let's see if we can jack this font up. So sort of ruined the rendering, but that may be a little bit more legible. That's not working. You can see I have a Linux i686, particular Gecko build, various other attributes, platform, operating system. These are two Navigator JavaScript objects that are queried. So I'm going to turn on Tor and reload this page. Hopefully I'm connected to Tor. Reload this page, and here's while that's reloading, we can have a look at the CSX exploit here. They were able to determine, yes, I've been to Google. Yes, I have been to /. So I've turned on Tor. Now if I reload this guy, we'll just switch to this next example. Here we have the time zone information. Obviously I'm using Pacific time. If I reload this guy, this should be addressed. Here all my plugins are listed. I can reload this guy. And CSS history, again, using no JavaScript whatsoever, they were able to use a CGI to see that a background image was fetched for the visited attribute of Google.com and determine that I had visited Google. And obviously that can also be used to determine if you've issued specific Google queries as well. So that didn't. Must have changed this. So here the CSS for I'm going to reload this. This guy looks like he got cut off. The CSS for the exploit was unable to determine, now that Tor was enabled, that I had visited Google, unable to determine that I had visited /. Over here, why did that fail? It looks like they only fetch part of the document there for some reason. So here in this CSS exploit, you can see that they were unable to tell that I visited Google now that I've enabled the Tor button. And it's not by clearing history. It is by hooking those extension interfaces, so your history is in fact preserved. Here's this thing finally loaded properly. You can see that the user agent has been reset to Windows. There's a different Gecko version, different Firefox, different Navigator object properties to obscure that. Time zone has been reset to GMT. And this guy looks like, and no plugins. I don't know why these things are only partially loading. So that pretty much covers every application layer vulnerability that we are aware of for Tor usage via the browser. So there's a couple, as I mentioned, there's a couple of random interesting technical details. Probably the only one that's really worth belaboring is the JavaScript hooking techniques. Those are, if you're curious about how I hook the date object, I think that's pretty interesting. Basically, I used JavaScript lexical scoping to conceal the original date instance, and then hook the JavaScript methods for basically all the date functions. I tried about 12 different ways to try and bypass that lexical scoping and access the original date object. I was unable to find any way to get past that. I looked at quite a bit of JavaScript references to try and find the scope object and all this other stuff. So please, if you're a JavaScript guru, have a look at your conference CD and have a look at that little code snippet and see if it looks legitimate to you. And if it doesn't, shoot me an email and tell me I'm crazy. But I did try and vet this thing pretty extensively. And pretty much every reference I could find on JavaScript did say that lexically scoped variables are an effective way of creating private member variables that other interfaces absolutely cannot access. So who knows if there's some hack that you can actually trick the browser into doing that. But as far as most JavaScript books were concerned, that was a legitimate way to hide that original object from any sort of access. So we're pretty much wrapping up. Some final thoughts. Tor security is not internet security. It's a superset. There's a lot more issues that you have to deal with. Adversary has different goals. They want to bypass your proxy settings. They want to get you to reveal unique identifiers. They want you to run plugins or what have you. And a lot of apps don't consider these sort of vulnerabilities as real vulnerabilities. So it's sort of an uphill battle. Here are some random people that have contributed various pieces to this. Scott Squires was the original Tor button author. Colin Jackson had the history blocking and cookie jar code. Johannes Renner is the Google Summer of Code student who did some TorFlow contributions for path selection. And of course, Nick and Roger are awesome for having built Tor, and some of my coworkers probably deserve a shout out for, signing expense reports and whatnot. So, what can you do if you really love Tor? There's a few things that you can do to help it out. On the conference CD, I've included a Linux script to do rate prioritization. So if you run a web server or whatever, you can run that script and prioritize all your shell server's traffic above Tor, and then you can run a Tor server without having it affect any of your